Hello pre-calc students. Here videos are going to be problem by problem, so you can select which ones you need to get extra assistance on. The domain of the problem, so we have a graph and we need to analyze the graph visually. And so understanding the domain of the problem, we know the domain is going to be from negative infinity to positive infinity, and once again, I'm coming up with these values just by looking at the graph and visualizing it. So I'll give you a verbal description on how I'm visualizing the graph. I'll give you a verbal description of how I am visualizing the graph, and then how I'm writing that in interval and set notation. So looking at the domain, I can see that this function is going on forever to the left side and off on forever to the right side. It doesn't look like there's ever a point where the graph is discontinuous, where there isn't anything on the domain. So for the interval notation, my apologies. For the interval notation, the domain is going to be from negative infinity in parentheses to infinity. In set notation, we can write this as x such that x is equal to, and this notation means all real numbers. It's like an R with an extra line through the middle. Alright, the range. The range is from the lowest y value to the highest y value. So to find the range, I look at the lowest y value. It looks like the lowest y value that goes a little bit below 2. So this is my approximation, but under assumption that this point and this point has a y coordinate of, let's say, negative 2.3. Under that assumption, the range could be negative 2.3 inclusive on the low end. You always start with the lowest value. To, look, the y value here goes up on forever, indicated by the arrow. So to infinity. And using set notation, we write that as x such that x is greater than or equal to negative 2.3. It is increasing, so now we're looking at intervals where the function is increasing. And increasing is when it has this positive direction, so it's increasing from left to right. Decreasing is when it's going down from left to right. So let's look at when it's increasing. Follow my cursor. Right now, the cursor is decreasing as the cursor is going down. Now, as I hit this inflection point right here, it starts increasing, then it's going to be decreasing, increasing. So let's map out those intervals. From, let's call that x value, let's call this point negative 1.5 to negative 2.3. Okay? It's going to be increasing in between negative 1.5 and 0. It's also going to be increasing from, let's call this 1.6, negative 2.3, that point right there. 1.6 to infinity. Now, these are just approximations, but if you can look at the graph and get a close enough approximation, you should be able to point out the correct answer on a multiple choice test very easily. Decreasing, just looking at the graph, it's decreasing from negative infinity to negative 1.5. It's also decreasing from 0 to 1.6. Alright. In set notation, this is going to be a long set notation. This is going to be x such that x is in between negative 1.5 and 0. So x is greater than 1.5 but less than 0. Or it's going to be greater than 1.6. X is greater than 1.6. For set notation, we're going to have x such that x is less than negative 1.5, or x is greater than 0 but less than 1.6. So that says 1.6. So let me just rewrite that. 0 is less than x is less than 1.6. All right. It's positive in between. It's positive from negative infinity to 2, from negative 1 to 1, and then from 2 to infinity. And I'm not going to force you to write that in set notation just because of the lack of space. It's negative between negative 2 and negative 1, and then 1 and 2. As far as end behavior is concerned, this is, hint, hint, this might be extra important to know end behavior. The limit as x approaches negative infinity is going to be of f of x is equal to infinity, and the limit as x approaches infinity of f of x is equal to infinity. So this is going to approach infinity looking at both end behaviors. All right, that's question 1. Try to be thorough. Thank you very much.